I'm here with the CEO of Xscape Photonics, Vivek Raghunathan. Vivek, please tell us, what is Xscape Photonics?
Xscape Photonics is a startup that spun out of Columbia University from the works done by three professors, Alex Gaeta, Professor Karen Bergman, and Professor Michal Lipson. And Yoshi and I, who joined them as the co-founders, started this company with the mission of wanting to enable our customers solve performance scaling problems for AI data center fabrics.
And you think the solution is WDM?
And we believe that WDM is the right way to solve the Xscape bandwidth problem that exists in the data center today.
So what is the current status? How do you plan to use WDM to solve the AI capacity challenges?
In order to maximize the bandwidth that you can escape out of GPU, the industry can learn from what has already been done in telecommunications, where a fiber can carry a lot of wavelengths on a single fiber without having any crosstalk, thereby improving bandwidth capacity onto a single fiber. And that uses a technology called wavelength division multiplexing, which is WDM. And a fiber at its core is only like 100 microns in diameter, 125 microns in diameter. And if you can carry like an 8 terabyte per second on a single fiber, you're looking at close to anywhere between 16 to 24 terabits per second per millimeter bandwidth, which is theoretically doable in terms of bandwidth escape density. So today, the industry is struggling to maximize how much of bandwidth you can escape out of a GPU. And the customers are struggling to figure out how to get to a stage where the GPU utilization can be maximized. And we are trying to address that problem by providing an additional step of bandwidth capacity improvement onto a single fiber, and not limit the ability to do that by fiber density and optical density, and translate the problem to more like a chip level and packaging problem.
And to achieve that long-term goal, you already put a product in the market. You're already addressing early adopters of the technology with a multi-wavelength programmable laser. Can you tell us more about this? We are really excited.
Our first go-to-market product is industry's first programmable multi-wavelength laser that can be programmed for different wavelength grids in terms of the number of wavelengths and the spacing between them. So today the customers use 4 wavelengths for a training cluster, 16 wavelengths for inference cluster, and we are able to communicate and we are able to program a single multi-wavelength laser for different use cases.
So you can define the amount of wavelengths and the grid size. You can define the distance between those wavelengths in the multi-wavelength laser, and you can program that, and you can switch it from one configuration to another.
That's exactly right. And the customers are not as keen on the ability to switch it at this stage, but we have customers interested in 4 wavelength in the LR4 grid. The customers are interested in 4 wavelength in the CWDM4 grid, and 16 wavelengths in the CWWDM MSA grid. And from an engineering standpoint, it makes our job easier if we can use the same laser to program it for different grids and serve different customer use cases.
And you brought us the laser.
Yeah, this is an image of a laser package that can emit up to 16 wavelengths onto a single fiber.
It's a chiplet size.
Yeah. And it's the size of probably smaller than my finger, right? And this can fit inside a module, it can fit on the board, it can fit on a package. So we are form factor and system implementation agnostic.
For these early adopters that you are trying to reach with this multi-wavelength laser, what do you want from them?
What I'm learning from them is that as the demand for bandwidth is skyrocketing, the optical footprint within the AI data center is going to go through a step increase in the capacity that it needs to support. And the existing capacity that the industry currently has is unable to meet the demands of these hyperscalers. The industry has a lot of appetite for figuring out what is the most cost optimized, efficient way for solving that bandwidth scaling problem without having to invest in new capital. And what we are providing is a silicon photonics platform where the capacity is unutilized today. Like it's not fully utilized. All the foundries have in way more capacity than the demand. And we are essentially saying that as the demand for these lasers are going up because of the optics demand going up, the existing capacity of the lasers is doesn't have to necessarily go up, and we can leverage the existing silicon photonic foundry capacity to meet that demand by coming up with a new way of like solving multi-wavelength generation.
2 weeks ago, we met at the Optica PECC Summit in Sunnyvale, hosted by Synopsys, and my conclusion was that hyperscalers are looking forward to try new technologies for GPU interconnects. However, there are two challenges, which is reliability and the big one, price. How you are addressing those?
It goes back to the same thought process around reducing the number of unreliable components in the network. Today, when you look at an optical transceiver pluggable unit, lasers and fibers are the most unreliable components in there that tend to fail. We are taking one piece of the puzzle there, which is the laser reliability. And as the number of lasers increase within a pluggable over time, the number of failure points within a pluggable is also going to go up. That increases the reliability concerns. So what we are saying is use a single laser and use a silicon photonic die to generate multiple frequencies out of a single laser. And we are introducing this concept of optically pumped laser that can be generated on silicon photonic die, which is fundamentally way more reliable. And we are making reducing the number of unreliable components in the industry inside a pluggable or inside an optical transceiver unit. So that addresses the reliability aspect of it. And from a cost standpoint, it's directly related to it in the sense that if you reduce the number of components by integrating all of them on a piece of silicon, the cost has to go down, right? And more than that, we are not investing any new capacity and capital to meet the demand, which means we don't necessarily have to pay additional premium to justify or to make up for that capital returns, right? Because of these reasons, we think our approach to solving this bandwidth problem solves both their concerns around reliability and pricing.
So if you want to try the world's first programmable laser with multi-wavelength, in which you can select the amount of wavelengths and the space between them, contact Vivek. Vivek, thank you very much and congratulations on the progress of Xscape. Bye-bye.
Thank you. Thanks a lot.